Good morning, dear students. In the previous class, chapter as is matter pure, we have discussed about the one of the separating technique, that is chromatography, where it is used to separate, different mixture of colors, And in today's class, we are going to discuss about how to separate the immiscible liquids. What is the separating method used to separate immiscible liquids and miscible liquids? Immiscible and miscible. Now, what is the meaning of immiscible and miscible? First, understand the miscible, which means, for example, when you mix alcohol and water, both of them are going to get mixed up easily. When you add water to the milk, the water and milk get mixed up easily. We cannot differentiate them. That is a miscible solution, miscible liquids. For example, when you add oil to the water, we can differentiate the two layers. The one which is less denser will float on the surface, and the one which is more denser will settle at the bottom. When you pour a cup of oil on water, it is going to settle on the surface of the water. That is called as what? Immiscible, which do not get mixed up easily, is called as immiscible. So what are the different methods or different techniques used to separate immiscible liquids and miscible liquids is our today's topic. Okay, now let's continue with the topic. Miscible liquids and immiscible liquids. Now you have understood what is an immiscible liquid. Example, water and oil. Okay. For example, you might have observed sometimes in the sea, in the ocean, the two ships gets collide to each other, or the ship will be in accident. So that in that time you can notice that the oil spillage will take place from the ship, and the oil will start floating on the surface of the water. This happened in Chennai, this happened in Visakhapatnam, this happened in Mumbai. Okay, so the oil will float on the surface of the water. It will not get mixed up with the water. That is immiscible solutions. And the next example, during this rainy season, we see the stagnant water surrounding our houses. And if you notice the health departments, they advise, if you have any stagnant water near your houses, pour a cup of kerosene or an oil. So that will prevent the breeding of mosquitoes. It is useful to control the mosquitoes. So how this kerosene is controlling? Kerosene is preventing the mosquitoes to stand on the surface of the water. So water and kerosene, they never mix up. Water, kerosene, or water, petrol, water, diesel, they do not get mixed up easily. So how to separate these two things? So here we are going to use a separating method, that is called as separating funnel. We use a separating funnel. Now, what is the structure of separating funnel and how it is going to be useful to separate this miscible or immiscible liquids? Separating funnel. Here we have the knob. Okay, so this is the rough diagram, rough structure for the separating funnel. Now, you have a mixture of oil and water. It is not getting mixed up. You need to separate both oil and water. Okay. Now, what I am going to do? I am going to pour the solution, pour the immiscible liquid. Okay, take the immiscible liquid. Immiscible liquid. Now, what is going to happen? Oil is less denser than the water. Oil is less denser than the water, and water is more denser than the oil. So, what is going to happen? The more denser liquid will settle at the bottom. Will settle at the bottom. This is a water, and here you have oil. Oil is less denser, so it will be on the surface, and water is the more denser, it is settling at the bottom. Okay, it is in the next layer. Now, when you turn on the knob, place a beaker here. When you turn on the knob, what is going to happen? Who is going to get separate first? The layer of solution which is there at the bottom. So now when you turn on the knob, slowly the water is collected in the beaker. Okay, water is collected in the beaker, and you turn off the knob. Okay, the water is left out of the separating funnel. You just turn off the knob. You turn off the knob. Now, who is remaining in the separating funnel? Oil. So this is how oil and water are separated using separating funnel. So separating funnel is used to separate the immiscible liquids. Immiscible liquids. Okay, separating funnel is used to separate the immiscible liquids. What are immiscible liquids? The 2 or 3 liquids, they are not getting mixed up easily. They do not get mixed up. You can easily differentiate the layers. You can easily differentiate the layers. So they cannot be separated by filtration or by decantation or by chromatography method. Then how it is separated? That is by using a separating funnel. That is by using separating funnel. The next important question: who is separated first? Which liquid is separated first? Oil or water? Water is separated first because its density is more and it will settle at the bottom. Oil density is less, so it is going to float on the surface of the water. Okay, so this is all about the separating funnel, immiscible liquids. Okay. Yes, dear students. So we have understood what is immiscible liquid, examples of immiscible liquid, and what is the suitable separating method or technique used to separate immiscible liquids. Now we will discuss how to separate a miscible liquid. How to separate miscible liquids. Okay. Now what are miscible liquids? When two solutions are brought or when two solutions are mixed, they are going to get mixed up completely. Uniform distribution of the solution will be there, and we cannot differentiate the components present in it. We cannot differentiate the components present in it. Right? There may be two or there may be three. For example, the water and alcohol. When you mix water and alcohol, they are going to get mixed up easily, and you cannot differentiate water and alcohol. Like you have differentiated water and kerosene, you cannot differentiate water and alcohol. Both of them gets mixed up easily. Both of them gets mixed up easily. Now you have to separate them. You have to separate them. In miscible liquids, we cannot identify where is water, where is alcohol, because they are mixed up. It's not like oil and water. They completely mixed up and you have to separate them. So the suitable separating method for miscible liquids is distillation. The method that we are going to use to separate the miscible liquids is distillation. Now what is distillation? What is distillation? That is evaporation followed by condensation. What is distillation? Evaporation followed by condensation. Evaporation followed condensation. What is evaporation here? Conversion of liquid to vapor. Now, what is condensation? Conversion of vapor to liquid. Vapor to liquid. Okay. Miscible liquids means the solutions get mixed up easily and looks like a single solution. Looks like a single liquid or single solution. Now, the suitable method to separate components in miscible liquid is distillation. What is distillation? Evaporation followed by condensation. Evaporation followed by condensation. What is happening during evaporation? Liquids are evaporated. What is happening in condensation? Vapors are converted to liquids. Vapors are converted to liquids. Now, then how this is taking place and what is the principle behind this evaporation and condensation? That is, that evaporation depends upon the boiling point of liquid. Boiling point of liquids. Now, what is boiling point? What is boiling point? The boiling point for the liquids from one liquid to another liquid will be different. From one liquid to another liquid will be different. So, based on this boiling point, we are going to carry out this distillation process. Okay, the boiling point of liquid. What is boiling point? The temperature at which the liquid starts boiling. Temperature at which liquid starts boiling. Now, what is happening in boiling? It converts from liquid to vapor. Water boils at 100 degrees Celsius. Water boils at 100 degrees Celsius. That means when you are heating the water, when you're boiling the water, it converts to vapors at 100 degrees Celsius. At 100 degrees Celsius. That is a boiling point of liquid, boiling point of water. The temperature at which the liquid starts converting to vapor is called as what? Boiling point. Example, the boiling point of water is 100 degrees Celsius. 100 degrees Celsius. Now, let us see how the distillation process is carried out to separate the miscible liquids. Let us see how it is going to happen. Now, take a tripod stand, burner, arrange the burner, and place the round bottom glass. Like to have a conical glass, there will be a round bottom glass. Round bottom glass. Fix it to the stand. Okay, fix it to the stand, and then you arrange a condenser. Okay, this is the stand, burner. This is round bottomed glass. Okay, now fix a condenser. Place another stand here. Take another round bottom glass. Okay, now what is happening in condenser? This is the inlet of cold water. Here is the outlet of water. This is condenser. Okay, condenser. So this is the entire setup for the distillation. Okay, here you have taken a stand, a burner, and a round bottom glass. So we are taking two round bottom glasses. Okay, now here you have condenser. Condenser means internally there is it will be this way. The water that is inlet and outlet are not going to mix up with the vapors. Okay. Now let us see what is happening. Now in this round bottom glass, I take a mixture of water and alcohol. Water and alcohol. Okay. So I am taking water and alcohol in the round bottom glass. Now I started heating. I started boiling. I started boiling. Now, what is going to happen? The liquid in the given mixture, which is having less boiling point, the liquid with less boiling point, BP, less boiling point will get evaporated first. Less boiling point will get evaporated first. I hope you have understood that. So water and alcohol are there in the round bottom of the glass. When I started heating, the liquid which is having less boiling point, the liquid which is having less boiling point starts evaporating. That means it converts from liquid to vapor. Liquid to vapor. Say for example, alcohol. Alcohol is having some around 60 degrees Celsius and water is having some around 100 degrees Celsius. Now, water boiling point is 100 and alcohol boiling point is 60. Now, who is going to get evaporated first? Alcohol or water? Alcohol gets evaporated first. That means it converts to vapors. Alcohol, which is present in this bottom of the glass, round bottom of the glass, will convert to vapors. So these vapors are passing through the condenser. Now, what is happening in condenser? We are allowing the cool water to pass through it. Cool water to pass through the condenser. Now, internally, the vapors are passing. Internally, the alcohol vapors are passing. So, what is going to happen to them? In this condenser, condensation is taking place. Here, condensation is taking place. And here, evaporation is taking place. In the round bottom of the glass, evaporation. In the round bottom of the glass, evaporation is taking place, and in the condenser, condensation is taking place. Here, liquids are converted to vapor, and here the vapors are converted to liquid. So the alcohol vapors which are passing through the condenser, they undergo condensation and convert to liquid, and that liquid are collected in the second class. This process will continue till all the alcohol in this first round bottom glass gets evaporated. Are you able to follow? So once all the alcohol is done, evaporated and condensed, then slowly the temperature increases to 100. So once the temperature started increasing from 60 to 70, 80, then you can turn off the flame. That means the thing which is collected, the liquid which is collected in the second round bottom glass is alcohol, and who is remaining in the first glass? That is water. So first, liquid with less boiling point gets evaporated. Liquid with less boiling point gets evaporated first, and it will undergo condensation. And the liquid with more boiling point will remain in the flask itself. Are you all able to follow? This is all about the distillation, where evaporation followed by condensation, which is used to separate the miscible liquids. Yes, dear students. So when you have two liquids in a given solution, we use distillation. Then what about the solution, or what about the liquid which has many components in it, and all of them are example for the miscible liquids? How to separate them? Example. Example, petroleum. Petroleum. This we have already studied in the class 8, coal and petroleum. Petroleum is a crude oil that consists many components, many substances. Example: diesel, kerosene, petrol, naphthalene ball, candle wax, shoe polish, right? Asphalt, Vaseline, paraffin. All these things are present in the petroleum, crude oil. How it is separated? How components from the crude oil are separated? Very good. That is fractional distillation. Fractional distillation. The best example, petroleum. Petroleum means crude oil, rock oil, crude oil. Petra means rock. Oleum means oil, rock oil. So in the rock oil, ancients do not know of the compound. They just use it for lighting the lamps and covering the leakages in the boats. Covering the leakages in the boats. It is used as a waterproof. That's it. But as the technology developed, people started knowing components. It contains the spirit, it contains diesel, petrol, kerosene, naphthalene ball, candle wax, asphalt. That means, so how they are separated? They are separated by fractional distillation. Fractional distillation. You know the fraction. That means separating the components from the given solution or given mixture one by one after the other. After the class, please go through the chapter coal and petroleum, fractional distillation of petroleum topic. Okay, so first, which is having a more boiling point, is separated in the fractional distillation. Which is having more boiling point is separated first, and then less, and finally we get the uncondensed gases. Right? We have a fractional distillation chamber in this way. Okay, the crude oil is passed here. And here you have layers. Okay, here you have different steps. Okay, so when the crude oil is heated and converted to vapors, you know what is the nature of vapor? What is the nature of the vapor? Vapor always moves in the upward direction. Vapors, the hot gases, always moves in the upward direction. So what is going to happen? Who is going to get separated first? The vapors which are having more boiling points. Who is going to separate first? Going to separate the which is having more boiling point, and which are not condensed here. They go to the next level, and next level. Finally, we get the uncondensed gases. So petroleum is one of the best example where it is separated by the fractional distillation. And also you have the next important one, that is during pandemic situation. You know, the second wave, you might have observed many of the patients are suffering with the lack of oxygen gas. Okay, so how this is taken, how it is prepared? Even in the atmosphere you have oxygen, why we are unable to take the oxygen, right? So that is a problem, right? In the atmosphere, the oxygen gas is mixed up with many atmospheric gases. Okay, so from that we have to take only oxygen gas. Second thing, if you observe the snacks packet, let us take the chips packet. You can see it is very big in size, right? We feel that it is packed with a lot of chips, but when you finish, you know, the gas is going to come out. The gas that is present in it is nitrogen gas. so only nitrogen gas is filled in it. How? So the atmospheric gases, the oxygen gas or nitrogen gas from the atmosphere is separated by using a fractional distillation method. By using a fractional distillation method. So petroleum and atmospheric, the gases from the atmosphere are separated by using what method? Fractional distillation. By using fractional distillation. Right? Those who are having textbooks, please do look at the page number 97. Please do look at the page number 97. Those who are having textbooks, please do take out the page number 97. Page number 97. Page number 97. Please look at there. You have air, atmospheric gas. In that atmospheric gas, when it is undergoing condensation, when the pressure is right, when you apply the pressure, under high pressures, what is going to happen? It is when you decrease the temperature and increase the pressure, the atmospheric gases are going to be trapped and they are going to get condensed. We are carrying out condensation process to the atmospheric gases. Now you can see the table is provided, a flow chart. Under the flow chart, you can see the table there: oxygen, argon, and nitrogen. Oxygen, argon, and nitrogen. Can you find that? So oxygen boiling point, look at here, oxygen boiling point is minus 183 degrees Celsius. Minus 183. That means at that temperature, oxygen is in which form? Liquid state. So you have to decrease the temperature. For example, now the room temperature is 25 degrees and now the temperature is 25 degrees. You need to decrease the temperature from 25 to where? Minus 183. Minus 183 degrees Celsius or less than that. So there it is going to what? Liquid state. The oxygen gas that is present in the atmosphere, will go down to the liquid state. At what temperature? At minus 183 degrees Celsius. Look at the nitrogen. At minus 196, the nitrogen liquid boils. Okay? At minus 196 degrees Celsius, it converts from liquid to vapor. So in order to store nitrogen in cylinder, you need to maintain the temperature what? At minus 196 degrees. Minus 196 degrees. How it happens? When you increase the pressure, the temperature decreases and it is going to get condensed. It is the oxygen gases or the atmospheric gases are going to get condensed at their respective temperatures. Okay, so this is all about the fractional distillation. Please go through this fractional distillation process. Okay, and turn the page to 98. Look at that paragraph. If we want oxygen gas from air, even in our government hospital, at the back side of the government hospital, you have this plant, oxygen gas preparation plant. Okay, whenever you get the time, you can just go and check it. Okay, and please look at that. We have to separate out all other gases present in that. So air is compressed by increasing the pressure. So when you increase the pressure, the gases are compressed. And then it is cooled by decreasing the temperature to get the liquid. So whatever the atmospheric gases are there, we are increasing the pressure, decreasing the temperature. They are condensed to convert to liquids. Right? Look at the paragraph. This liquid air is allowed to warm up slowly in the fractional distillation column where gas is separated at different temperature depending upon their boiling points. Depending upon their boiling points. Look at the first thing. First, look at the diagram there. So filters, air is trapped under pressure. It is passed to the freezing point where it is condensed. It is condensed and compressed and stored as a liquid oxygen. Look at the last box. Look at the last one. You can see there liquid oxygen. Liquid oxygen. So this liquid oxygen is stored in the cylinders. Stored in the cylinders. Okay, so this is all about the distillation and fractional distillation. Fractional distillation is used to separate the miscible liquids or miscible solutions. Example, petroleum and gases from the atmosphere. Gases from the atmosphere are separated by using this fractional distillation. By the fractional distillation. And here you are provided a questions in the think and discuss. Please look at that think and discuss. Please look at that think and discuss, and that is going to be your homework for today. Okay. So in today's class, we have studied how to separate miscible liquids and immiscible liquids. Immiscible liquids are separated by separating funnel, and miscible liquids are separated by fractional distillation. Fractional distillation. This is all about for today's class. If you have any questions, you can put it